Hello, good afternoon. I'm Modestha from the Sustainable AI Lab, and this afternoon we'll be looking at gender and AI, or AI and gender. We originally had three presentations, but the first presenter is unwell, so she couldn't join us. So we'll skip that and we'll move to the next presenter. That will be in person, and the last presentation will be online. As we've already been doing, each presentation is for 20 minutes, so please keep your phones on silent so that the presenters can have some quiet and those online can also hear whatever is going on here. So the presenter now is Camilla. You taught me your name. Quaresmini. Yeah, sorry I didn't mess it up. Yeah, they're going to present on inclusive models of gender for sustainable AI. They're also affiliated to Politecnico di Milano. So you have the floor, you have 20 minutes. I will be signaling you and we'll have a conversation after that.
Okay, thank you very much. Can you hear me? Okay. Hi everyone, I am Camilla Quaresmini. I'm a philosopher, but now I'm working in an engineering context in Politecnico di Milano. I'm working on fairness in AI systems. And the title of this talk is Inclusive Models of Gender for Sustainable AI. And today I will present you a joint work with Giuseppe Primiero, which was my logic professor at the philosophy department of University of Milan, where I did my master degree. And we started from an important problem, that of AI algorithms reflect technical problems originating with mislabeling data. And even if there exist systems which aim to mitigate bias, actually, systems are not really guarded against bias. And in particular, we consider this problem from the point of view of information quality dimensions. I have just said that there are several tools to mitigate bias in dataset. Here we have three examples. We have Equitas, AIF by IBM, and CleanLab, and we analyzed them. And we noted that they define fairness focusing on the mere accuracy dimension. And this is a problem. In particular, we take CleanLab as a case study. And the first assumption of CleanLab is that data are categorical, so they fit one label. And they, given that assumption, they give a mapping between variables where to y star is assigned the correct label and to tilde y the wrong one. So they compute the probability that label I is wrong given that label j is correct. What is the point? The point is that this type of strategy cannot deal with some kind of gender bias. And to be more concrete, I have our first case, that of an incomplete label set. If you consider a data point represented by a non-binary individual, the actual label for this data point is missing. You have me as a perfect example because I have always been labeled male, which is incorrect. But actually, it's not a correct classification for this type of data point is not possible. And to solve this problem, you can implement a larger partition of labels. So you can look at the label set from a high level of abstraction, and you can add, for example, a non-binary tag or other tags. However, this is a limited strategy as it is static, and it is not sufficient to deal with the second case, which is that of an inconsistent data point. So if you consider a data point which is represented by a transgender individual, for which the label as such may change over time, you cannot just add another tag like a transgender tag, because in our opinion this is not sufficient. And as an example, you have the famous actor Elliot Page, which in a previous time, was correctly labeled female, and in a later time is correctly labeled male. And in this case, an extension of the label set is misleading, as I said, because we want to ensure a strategy for the changing of the correct label over time. And coming to our philosophical stand, we state that the assumption that completeness and accuracy dimensions are the only relevant data quality dimensions for classification tasks is wrong. In fact, there exists a huge literature on data and information quality which provides a number of dimensions that can help improving classification and bias mitigation. And in particular, we believe an important starting point is represented by adding the dimension of timeliness, which has to do with how much data are up to date. And to be more concrete, our strategy is to add a time frame, and then we can say that given the label set is complete at a previous time, it can be incomplete at a later time, for the first case in particular, and for the second one, we can say that given the label I is correct for a data point D at a previous time, it can be incorrect at a later time. What about implementing this strategy in CleanLab? The initial assumption was that data are categorical, so that they fit one label. But now the assumption becomes that the probability value of a given label I being wrong given a label J is correct may change over time. So we give the same mapping y star to tilde y between variables, where I repeat, to y star is assigned the correct label and to tilde y the wrong one. And we compute the probability that label I is wrong at a later time, given that the label J was correct at a previous time. So what we do is to use formal methods for reasoning about the temporal changing of the behavior of the classification system when the word which is under classification changes. And the expected result is that this type of data point will be recognized as the same data point, because here we use the Amazon recognition, which recognizes the first image as female and the second one as male. But for Amazon recognition, this is not the same data point. We want the recognition of the same data point. So that is the point. This is our approach to fairness. We state that an objective of the epistemic and formal analysis of AI system is to provide a plausible definition of fairness that is not reduced to mere accuracy dimension. And in particular, in our model, fairness is the result of two quality dimensions defined over time. The first one is the completeness of the label set with respect to the population of interest. And the second one is the reliability of the system as a reduction of the error rate. Here, now we have a logic formalization of useful dimensions. We start from completeness of the label set, which means that label set is complete if at any time steps in the time frame it exists for every data point a correct label. And the second one is reliability. Here we computed epsilon, which is the change rate, and it shows how accuracy of the system deteriorates over time. So if the change rate does not exceed a safe value p, the system is considered reliable, and so it is accurate over time. Otherwise, the system is not reliable. And here we come to our fairness definition. A system is fair only if it is reliable over time and if its label set is complete over time. Even if we know that those dimensions are not sufficient, we think that they are necessary. And to conclude, we have seen how fairness is not just maximizing accuracy, and that current classification methods are rooted on 3 assumptions on gender, the binarism, so you can be recognized as male or female, and this is a kind of ontological errors today. And the staticity, so once you have assigned a gender label, this is your label and you cannot change it. And also the physical aspect as a proxy of gender identity. So oops, sorry, I don't know. So I have finished. We hope that this work can help in changing this type of paradigm, and we hope that this could lay the ground for an extension, thank you, of associated assessment tools. We have an available preprint if you want to deepen under the name Data Quality Dimensions for Fair AI, and thank you very much for your attention.
You stayed, you did less than your time. Thank you. So the floor is opened. If there are any questions, any contributions, both those of us here in person and online, you can ask your questions, please. Any questions? Okay, so while we think through it, I want you to speak more about your theory of fairness, so that how they apply properly in ensuring that there is no discrimination against gender by not doing the non-binary thing. Can you talk more about that? It's not very...
Yeah, in our opinion, adding the timeliness dimension can help mitigating those type of bias, and so we can reach fairness if we also consider the timeliness dimension. And you can see in those 2 examples that this dimension is really crucial, because if you do not consider it, you cannot deal with those type of problem. And sometimes, very often, when you think about gender bias, you always think about it in terms of male and female bias. And okay, there is this type of bias, but there is also a non-binary side which is not really considered for me, in my opinion.
Okay, but can you throw more light on how the time factor really works? How, you said the property should be enduring over time, and that is how you can tell if the depiction of someone as either male or female or both is fair. How does that practically, how does that work?
Practically, you have to implement in the code of those type of tools like a timeliness dimension. I don't know how to do, this is only a formal proposal, but we don't have any real implementation. But if you that are the programmer consider when you are writing the code, if you consider the time, you can deal with those type of bias, because if you do not consider it, you cannot classify correctly this kind of identities.
Any questions from the audience?
Thanks, that was great. Just a quick thought about how this might translate into, or how, so here's just the example I have of something that was left out of the examples. So if you have an intersex individual and you're looking to fairly identify, right? are there any dimensions that need to be considered? Or is there a way that the three that you mentioned, the timeliness and the accuracy and everything, can tackle that sort of issue?
Yeah, thank you. For the moment, we have focused on those type of those dimensions because in the literature there are like 200 dimensions. So, in our opinion, those are the starting point, the more important. I have used my case because I have been misgendered, so I am starting to think about how to deal with the type of data point which are like me. But I know there are others identities, and we hope to be able to reason about other solutions. Yeah, thank you.
Any others?
Thank you for your talk, and
Thank you.
It's maybe a comment and a request for clarification because it was a very complex talk. I come from philosophy, so some of the things were difficult for me to comprehend. But it seems like you're touching on some fundamental aspects, I think, misalignments in developing AI as socio-technical systems. Because on the one hand, you touch on fluidity of sex and gender and also of one's perception of that, right? Which is the experiential part. On the other part, this is a codification where a system needs to maintain some stability to be able to perform. Also what you're talking about, the accuracy and all. So we've also seen how in attempts to provide more fairness and justice in these systems, sex and gender references are at all excluded in this very naive attempt to prevent the biasing. But what we see, of course, in reality is that they become more biased because of the learned stereotypes that the system does. How does your solution speak to this tension between, on the one hand, this fluidity of experience, of gender and of sex as individual lived, with this attempt to codify and basically some of the solutions that you also proposed? Thanks.
Yeah, thank you. This is a problem, I know. I don't want to justify in any kind of ways the automatic gender recognition tools because I don't think they are, how can I say, fair tools, okay? But we wanted to think about formal solution to try to make those tools more fair than they are right now. But I think that this type of identity, so gender identity, is not really codifiable, okay? So this is my opinion, but I don't want to stop me in saying, okay, we have not to use those tools. I would like to reason, I like to reason about other possible solutions. Thank you.
Okay. Any other questions, both online and in person? Okay. All right. So I still want to really understand how the model you've put across can help developers produce more fair tools so that people are not discriminated against. So if I'm a developer, for example, what are the categories that I'm going to project out there to be able to identify somebody as non-binary, gender or even transgender, or so that everybody is included, all forms of gender are included. I just want to understand how this developer is going to be able to do this by the solution that you're proposing.
I think that an interdisciplinary work is crucial. So a developer has to work with other kind of academics academics, and a developer has to have a dialogue with other people that studies, like, for example, philosophy, in my case, or social sciences. In this case, experts of sexual identities. And in this kind of interdisciplinary dialogue, they can reach maybe a solution to be more fair, I think.
Okay, thank you. Okay, if there are no further questions, can we thank Camilla and welcome the next presenter, if there are no further questions. Okay, thank you, Camilla, for the presentation.